This is Modern Attenuation, version 1, Governance of Energy, Signal, and Boundary. It's a short booklet built from 3 related works that all point at the same inversion. Most people hear the word attenuation and they think one thing: loss, something weak, something undesirable, something to minimize with amplification, filtering, or brute force power. But that framing is incomplete, and it keeps repeating the same failure in different industries under different names. Attenuation is not merely what happens after a signal travels. It is part of how the system is governed while the signal travels. It is boundary behavior. It is structure. It is the condition that enforces stability, selectivity, and convergence. This booklet brings together 3 steps in a progression. The first is a physical mechanism in reception. The second is a general theory applied to wireless energy delivery. The third is an environmental extension, clearly labeled hypothetical, about how atmospheric conditions might change propagation and how civilian sensing could model anomalies if they existed. The first paper is titled Mechanically Mediated Closed-Loop Attenuation Modulation for Signal Reception. It introduces a conceptual model where attenuation is treated as an information-bearing parameter space, not a scalar penalty. The argument is that attenuation encodes the interaction between a signal, its propagation environment, and the physical coupling geometry of the receiver. Instead of locking a receiver into a single configuration and then trying to rescue the result with more electronic gain, the framework treats reception as something that can explore attenuation space. The core insight is that small, controlled mechanical perturbations of the physical receive path can measurably change attenuation behavior without injecting energy at the carrier frequency. That distinction is critical. The system is not amplifying the signal. It is reshaping boundary conditions that govern coupling. And the moment you combine that with feedback, it becomes more than a thought experiment. In the closed-loop framing, the receiver monitors real-time metrics: coherence, stability, phase behavior, attenuation patterns, applies controlled perturbations, evaluates the response computationally, and adjusts dynamically. The receiver is no longer stuck at one operating point. It can search for more informative operating states. This is why the paper is intentionally described as conceptual and non-procedural. It does not prescribe a specific mechanical embodiment. It identifies a general class of systems, ones in which boundary conditions can be intentionally and reversibly varied, and where closed-loop feedback can navigate attenuation as a structured domain. The second paper is titled Attenuation as a Control Primitive in Wireless Energy Transfer. It takes the same inversion and applies it to a field-level problem that keeps stalling: scalable, stable wireless power delivery outside controlled conditions. Wireless energy research often emphasizes transmission strength, resonance optimization, coherence, and directional efficiency. Loss is treated as the enemy. But the persistent problem is instability when scaling, dispersion, environmental coupling failures, multipath chaos, resonance drift, shrinking safety margins. The argument here is that the limitation is not simply engineering difficulty. It is a conceptual omission: the failure to treat attenuation as an active control variable. When systems are optimized to minimize attenuation at all costs, they remove the very mechanisms that enforce stability and selectivity. Then, when more power is added, it doesn't create reliability. It magnifies sensitivity to environmental boundaries and increases stochastic behavior. Field presence gets confused with governed delivery. The paper reframes attenuation as boundary conditioning. In wired systems, reliability comes from boundaries: transmission lines, waveguides, cavities, dielectric structures. Wireless power tries to remove physical boundaries without replacing them with functional equivalents. The proposed inversion is attenuation-first thinking. Treat dissipation profiles and loss gradients as the governing constraint that encodes virtual boundaries in open space. The objective is not maximum field strength everywhere. The objective is controlled convergence where it is intended, and controlled decay where it is not. So the key claim is simple: scalable wireless energy requires governance, not just gain. Attenuation is the stabilizing feedback that suppresses unintended coupling and enforces convergence. Design loss before gain. Optimize convergence, not raw strength. The third paper is titled Hypothetical Role of Atmospheric Nanoparticulates in Signal Attenuation and Ionospheric Manipulation. This one is a position paper, and it is explicit about its scope. It does not claim real-world deployment. It does not allege actors. It models hypothetical conditions and asks what would be measurable if the atmosphere's dielectric or conductive properties were altered by particulate density. The focus is on how atmospheric nanoparticulates could, in theory, modify permittivity and conductivity, change scattering behavior, and shift attenuation patterns across microwave, Q-band, and HF regimes. It also explores hypothetical interactions with excitation thresholds in upper atmosphere phenomena with careful language that keeps the work in the modeling domain. Then it connects that modeling to a civilian detection question. If anomalous propagation signatures existed, whether from natural causes or otherwise, could an open civilian sensing network detect them? That's where the Dish Sentinel network model is referenced. Attenuation mapping across nodes, correlation of unusual fade depth and rate of change, phase shift anomalies, and structured comparisons between natural atmospheric models and outlier signatures. The ethical position is not accusation, it's access. If atmospheric modification technologies ever exist in any form, detection and modeling should not be monopolized by closed systems. The civilian path is transparency, open data, open methods, responsible interpretation. Now, here is what matters across all three works. The unification is not a gadget. It is a principle. Attenuation governs stability. It governs selectivity. It governs convergence. It encodes boundary behavior across mechanical, electromagnetic, and environmental domains. And once you understand that, you stop seeing attenuation as a deficiency and start seeing it as a design space. A space where controlled loss can increase informational yield, improve predictability, and reduce instability, not by overpowering the environment, but by shaping the boundary conditions that decide what is allowed to couple. This is why the booklet is titled Governance of Energy, Signal, and Boundary. It is not about romanticizing loss. It is about recognizing what loss does in real systems and using that understanding to build architectures that are stable enough to trust. The license posture is stewardship. These are released openly, no patents claimed, no restrictions imposed. The intent is responsible exploration and validation by others, because the claim is not that attenuation is optional. The claim is that attenuation is fundamental, and treating it as fundamental changes what becomes possible. If you did, you'll find hundreds more just like it waiting for you on our TikTok, this YouTube channel, the homepage, and especially ivorytowerjournal.com. We also have full podcast versions of every episode under the same name, Testoeo. Come join us. The next collapse of the old paradigm drops in 48 hours. See you there.